Right. So that's basically unidirectional versus bidirectional relationships where, one type has a property that points to another and that's it. Or, it's two-way is bidirectional where one type will have a property that points to another and then that one will have a property that points back to the first, right? Okay, any question about relationships? I kind of mangled the explanation a little bit, but hopefully you've seen these before. Okay. I need to click, of course. I always forget. I didn't the first time, but I did this time, so it's just fun. Okay, cool. So, this is what it looks like when we're dealing with tables, okay? So we know what it looks like with memory. We use memory just as great, right? Okay, so let's look at our pizza table from earlier, okay? So we had that filled up with a bunch of crusts, right? And crust, names, right, for a particular, pizza. Oh, it's a plain pizza with hand-tossed crust and cheese, right? Okay, well now let's say we have introduced a crust table, okay? So now that we have a crust table and it's just a list of possible crusts, right? Now, instead of using the name in the pizza table, we would use the ID of that record in the crust table. So, for example, now these say 1 instead of hand-tossed. Likewise, this thin would now say 2. And then, stuffed would say 3 if I'd finished, which I guess I didn't. I thought I had, but whatever. Also didn't magic move very well. It was like just fading in and out. It's very disappointing. Apologies. Okay, right. So you refer to other tables by their ID. If you're curious to know, this is called a foreign key in SQL. You don't need to know that information, but it's fun. The ID for rows on a table that, that's the ID of that table, those are called primary keys. Again, you don't really need to know that. It's just fun to know. Another way that you can represent relationships other than just by drawing the tables or doing these like one-to-one, one-to-many things that I've done, you can use relationship diagrams. There are a ton of these, EMRs, sort of, things like that. And they help you kind of understand how these things tie to each other, right? How they're connected to each other. You'll have your type or your entity as the top, and then you'll have a bunch of rows, and those represent columns. And then you don't show the instances because this is just a relationship diagram. It shows how they relate to each other. It doesn't show how a particular set of tables is set up, just how they could be set up, right? This is kind of how you'd represent a schema. This or this, this works fine, right? There's a bunch of different ways that you can do it. So, any questions about relationships here that we've talked about with the tables and the relationship diagram and anything? Okay, cool. All right. So, there are things called ORMs, object relational mappers. Object relationships, as I showed you, can be quite complex. I messed up one of the examples just because it was late at night, right? And that table was literally showing pizza and crust, okay? And it took up most of the slide. They can get quite complicated, all right? So, because object relationships are complicated, there are these things called ORMs. We, as application programmers, just want to think in terms of types. All we care about are types. Is it struct? Is it a reference? Is it a class? Value, reference type, who cares, right? We just want to be like, okay, cool, we have this type and it has these properties, right? And maybe it's conforming to a protocol, we don't know, right? But that's how we prefer to think in memory, in terms of what we want to work on, right? We don't want to think about databases and records and tables and entities and whatever attributes are. I know attributes are a thing, but I don't think they're columns, but whatever, right? Like we want to think of them whatever, right? We just want to think about what's in memory, right? ORMs allow engineers, application engineers like us, who are not database focused, to do that. When you use ORMs, you create model code that looks more like the code that we use, right? it's got types, it has properties, right, and all this other stuff. But there are differences, right? It'll look a little different typically, right? You'll have to define some relationship stuff and do other things, right? But the foreign keys and the primary keys and how joins are handled, which we did not even talk about because I didn't want to bore you to death. I just wanted to bore you a little. That's all handled for you. You don't have to worry about it, right? So ORMs create an abstraction layer between a database and your code so that you don't have to worry about it. They are typically auto-generated from a schema, so you don't even have to write the model types in an ORM. They're made for you, and you just use them, okay? Swift data is not an ORM. Apple will be very quick to say that Swift data is not an ORM. It does not do the exact same things ORM do. And the reason why Swift data is not an ORM is because that last thing I said, ORMs automatically generate your model data for you from a schema. And they assume that you have a schema and a database already set up, and they generate code from that information, okay? Swift data is not an ORM. Oh no, I have to click through all of them. Swift data is not an ORM because it does not assume you are starting from a place of having a database or even a relational database. Swift data is an abstraction on the concept of persistence, okay? So by default, Swift data wraps around SQLite, a SQLite database. That's what Apple automatically gives you under the hood for Swift data. However, people online have created, or you could create, specialized transport wrappers that change it so that Swift data can wrap around any other type of persistence, okay? So you could wrap around MongoDB and actually store your things in human readable JSON. You could wrap around PostgreSQL, okay? There's a bunch of different things you can do. And because of that, because it doesn't need actually a database with a schema underneath of it, it's not an ORM because you're not generating models automatically from a preset type of thing, right? You are instead defining models in code that you can then use. And the models in code do borrow some structure concepts from relational databases, but it's not one-to-one and it's not exact because they wanted to make it easy to use compared to how ORMs are, which ORMs, if you ask anyone who's used one, tend to be a pain in the ass to use. They tend to be obtuse, they have weird errors, and you just run into all sorts of problems, okay? So, Swift data is not an ORM. Apple will say that over and over again if anyone asks. The underlying database is SQLite, but it can be swapped out. It's an abstraction of persistence relationships so that when we load something back in, we can actually have the object graph. And we can also load the object graph only by the things that we need, right? If we load up pizza type number 1, well, we need all the toppings it refers to, but we don't need to load all toppings in existence into memory. We can just load the rows that we want from that table. So we end up with a much smaller memory footprint as well while we're working with data that was persisted, right? But, you know, at the end of the day, you can kind of think of it like an ORM, right? As developers, we tend to think of ORMs as layers that sit on top of a database that allow us to interact with the database in a way that doesn't feel like actually writing, you know, queries in SQL, right? Or to SQL. Oh gosh, what's the querying language? Is it SQL? It's SQL, right? That's what they call it when you're querying SQL databases. Oh man, I remember.
Query. Query.
Query? Yeah. When you search through a database, don't worry about it. It's not a big deal. It's not important to us because we're not doing it. So you know, my memory. I just realized I had a missing index in there. I can't remember. Like a part of me wants to say it's writing a SQL query, but I feel like there's a specific language that you use to do that, and I just can't remember what it is. Doesn't matter. Anyway, point is, you can think of it kind of like an ORM. The main difference is this ORM, you don't have to write the database. You don't have to write the schema. You don't have to load it in. Apple does all of that for you. All you have to do is define your types in a way that could work with Swift data, right? So, the way that we use Swift data to do persistence is very simple. It sounds very simple. It ends up being semi-complicated. Persistence is always complicated, right? They tried to make it as simple as they could. They mostly succeeded, but there's some weird stuff, right? Of course. So, especially seeing as this is very new. Swift data came out in 2023, WWDC 2023. So, less than 2 years ago is how fresh this technology is. So it's going to take a while for it to like refine and season and all that stuff, right? Again, just like Swift UI, right? It's been out for what, 5 years now? And we've talked about how navigation view got completely replaced by navigation stack, or sorry, not stack, navigation destination. The whole concept of a navigation view just disappeared in 2022, right? So it takes Apple a few years to kind of land on exactly how they want a new technology to be. So we're now early adopters of Swift data. And everything, all the risk that comes with being an early adopter, okay? Everything I tell you today could change in June of this year, right? So keep that in mind. Okay, so in Swift data, you define tables, you define your schema in code when you define your data types, right? When you define your models, okay? So when you have a class that you want to be a table or an entity or whatever that gets persisted, you annotate it with the @model macro in front of the type. And that's all you do, okay? If you want to have a column in your database, those are properties on @model types. All your properties get persisted as columns on your model types, right? If you want to have a row, that is an instance of your model type, okay? Any instances of your model types that you choose to persist become rows in the table that is defined by the type of your model, okay? Relationships are properties that point to other @model types, and we might add extra information using @relationship. We'll be looking at that during the coding segment, okay? Relationships are where things get kind of dicey with Swift data. Everything else works really well. Relationships are kind of where things get dicey, and that's because that's where things always get dicey with databases, right? Okay, so Swift data persistence layers. In Swift data, you create, when you want to use Swift data in your app, the first thing you have to do, define your models, okay? And then there is a type called schema, and it takes in an array of models, right? So you've got your pizza.self and crust.self and toppings.self, and you pass those in as an array into your schema type initializer, and then you just kind of pass that to Swift data. And it's like, cool, we've built your database for you. Awesome, good job, right? A container creates a local store with the schema. So when I said you pass your schema to Swift data, what I mean to say is you pass it into the container's initializer. So you create a container, right? And that is a in-memory representation of your database for you, right? That is the local store on disk with the particular schema that you have defined, right? Again, of note, it's an abstraction, so it's not actually the local data store, okay? A context is a special buffer object. So this is a type inside of a container that allows you to read and write safely, okay? Because a container and databases are slow, you run into things where there are collisions, where if you have multiple threads that are trying to read and write to the database at the same time, right, then you'll have all sorts of memory errors and issues where, oh, you persisted this data to the database, but then you persisted something different from somewhere else, and that's causing a collision and an issue and all sorts of stuff, right? And there's different layers of handling it, and context is the highest level of layer that you need to worry about. And basically, context is where you put instances that you want to get saved. And it's also what you query when you want to get rows and turn them into instances. All right? So, to persist the data, save it to the context. Handles saving and loading. App model types that are not saved are what's called detached. So if you had an instance of a model type in memory that has not been added to the context, you haven't put it into the context, it's detached. It will not get saved. It will not get persisted when your app closes, okay? It will be lost, right? So anytime you have an instance of a model type that is not saved, it's detached. And you might like that. You might prefer that. You might have, I don't know, a sheet that comes up that allows users to create a new version of your model that they're editing and they're adding to it and all that stuff. And you don't want that saved necessarily into your database because they're not done with it yet. It's not complete, right? So it's detached until you save it by adding it to the context. When the user hits, cool, I'm done, save, right? Once they hit save, then you just shove that model into attached. And once you've shoved it into into the context, then it becomes attached. Once a model is attached to the data store or to the context, then it will get saved automatically by Swift data when the user does things like navigate to a new screen or close the app or whatever, right? It saves it when it needs to. It doesn't do it any time before. Unless you call context.save and force it to happen, which Apple prefers that you not. They want you to trust them. However, of course, because Swift data is a new technology, there are edge cases, so you might want to use context.save every once in a while. Okay, and that's it about persistence. I think I went over what I wanted to, so we're at 1:15. We're going to take a 10-minute break, and then we will do some Swift data coding for much of the rest of the class before we talk a little bit about structuring data models in your apps. So, cool. Any questions before I turn things off and we start the break? Cool. Okay. Let me shut this off.